In 2008, astronomers announced that they had found a gun, not a metaphor, a real mechanism 8,000 light years from here, a dying star called Wolf-Rayet 104, capable of stripping a quarter of the ozone off this planet in a burst lasting about 10 seconds. And, according to every measurement anyone had, it was aimed almost directly at us. It sits in the constellation Sagittarius, a pair of stars at the end of their lives, wrapped in a spiral of carbon soot, roughly the width of our outer solar system, turning once every 241 days. For most of 2 decades, it was the most quietly disturbing object in the catalogue. Not because it was the largest, or the nearest, or the brightest, because of its angle. Then, in March of last year, a team at the Keck Observatory in Hawaii published the measurement that took it all back. The orbit is tilted. The beam will miss. We are not standing in front of it. You would think that is where the story ends. The relief is the part that should worry you. April 1999. Peter Toothill, John Monnier, and William Danshee are doing something to the Keck 1 telescope that sounds like vandalism. Keck is, at the time, the largest optical telescope on Earth, 10 meters of mirror, 4,000 meters up on Mauna Kea. And they are covering almost all of it. A mask goes over the light path, blocking the mirror down to a scatter of small holes. There is a reason. Air moves, and the bigger your mirror, the more moving air you are looking through, and the worse it smears the image. Block everything except a handful of tiny apertures, though, and each surviving beam passes through a patch of sky small enough to be still. Let those beams interfere, and you can rebuild an image sharper than the whole mirror could ever have given you. You throw away most of your light to buy detail. What came back had never been seen before. A spiral, not a smudge, not a shell, not the ragged bubble you get around most dying stars. A clean, tightly wound, geometrically perfect spiral, glowing in the infrared 8,000 light years away. They published it in Nature that April. It was the first object of its kind ever imaged, and it earned a nickname that stuck, the pinwheel. It remains one of the most beautiful images produced by 20th century astronomy. It took another 9 years for anyone to work out what it was actually telling us. The machine that makes it is simple enough to build in your head. 2 stars orbit each other, about twice the distance from the Earth to the Sun. One is a Wolf-Rayet star, around 13 times the mass of our Sun. The other is a hotter, heavier companion, roughly 30 solar masses. Both are shedding themselves into space at enormous speed. Where the 2 lines collide, they compress, they cool, and carbon condenses out of the wreckage into soot. Then the pair rotates, and the soot gets laid down behind them in a curve. It is the same shape a garden sprinkler draws on a path. Water leaves in a straight line, the head turns, and what ends up written on the ground is a spiral. It is worth pausing on what this thing is actually made of, because the word dust does it no favors. It is soot. Chemically, it is not far off candle smoke, or the black on the inside of a chimney, carbon that condensed out of a collision between 2 stellar winds. And the structure it forms is about 160 times the distance from the Earth to the Sun, from one side to the other. A smear of soot, nearly 3 times the width of Neptune's orbit, drawn by 2 stars in the act of dying. Hold on to that, because it matters later than you think. The spiral is not decoration. The spiral is a recording of the orbit. It is the only physical trace we have of how those 2 stars are moving, printed at a scale we can actually photograph. And the problem was never the spiral itself. The problem was the shape of it. Think about what a sprinkler pattern looks like from different positions. Stand directly above it, looking straight down the axis of the spin, and you see the full spiral, open and symmetrical, exactly as it was drawn. Now crouch and look across it at ground level. The spiral collapses. It flattens into a bar, an ellipse, a smear of overlapping arcs. Every degree you move away from overhead, squashes the pattern a little more. This works in reverse. Hand someone a photograph of a spiral and ask them where the camera was standing, and they can answer. The geometry is unforgiving. A perfectly open, perfectly circular spiral can only be photographed from one place, near the axis. R104's spiral is almost perfectly open. When Tuthill's team ran the fit properly, the number that came out was 12 degrees. 12 degrees away from looking straight down the barrel of that system, with an uncertainty that ran from dead on to about 16. For almost anything else in the sky, that is a pleasant piece of geometry and nothing more. The orientation of a star does not usually matter to anybody. It matters for this one, because of what a Wolf-Rayet star does at the end. A Wolf-Rayet star is what a very large star becomes when it starts running out of room. These begin at 20, 30, 40 times the mass of the sun, and they burn so violently they cannot hold onto their own outer layers. The hydrogen envelope is blown off entirely, leaving the naked core, fusing heavier and heavier elements, radiating so hard that its own light drives its surface into space at over 1,000 kilometers a second. That is not an atmosphere. That is a star dismantling itself in public. It cannot continue. A star in this state has at most a few 100,000 years left, and the people who study them use the phrase ticking bomb literally. When one finally goes, the core collapses into a black hole, and the material still falling inward piles into a disk. Some of it never arrives. It gets flung back out along the rotation axis in two opposing jets at very nearly the speed of light. The leading explanation for what we call a long gamma ray burst, the most energetic thing the universe has done since it started. And here's the detail that turns astronomy into a threat assessment. A gamma ray burst does not expand as a sphere. It is a beam. The working rule for how wide that beam opens is about 12 degrees. 12. The same number arrived at from completely separate evidence, which left one question worth asking. What does a beam like that do when it arrives? Less than you would expect, and far worse. At 8,000 light years, there is no wall of fire. The sky does not turn white. Most people alive when it arrived would notice nothing at all. And that is not the reassuring detail it sounds like, because the damage is not heat. It is chemistry. Gamma radiation hits the upper atmosphere and breaks apart molecular nitrogen, one of the most stubborn bonds there is. The freed nitrogen finds oxygen and becomes nitric oxide. And nitric oxide destroys ozone catalytically. A single molecule does not break one ozone molecule and stop. It breaks one, survives intact, and goes looking for the next. Modeling of a nearby burst inside our own galaxy puts the loss at up to half the ozone column within weeks, with 10% still missing 5 years later. For this system specifically, the estimate came in at about a quarter of the column, from a burst lasting maybe 10 seconds. 10 seconds, and then years of consequences, roughly 3 times the ultraviolet reaching the ground, on the crops, on the plankton, on everything, without the sense to stay indoors. The genuinely unpleasant part is the timing. A gamma ray burst travels at the speed of light. So, the light that would tell you it happened arrives at the same instant as the radiation. There is no early warning. There cannot be one. The message and the damage are the same photons. We may already have one in the record. 440 million years ago, at the end of the Ordovician, something removed roughly 60% of marine invertebrate genera. In 2004, Mellott and Thomas proposed a gamma ray burst as the trigger. It is a hypothesis, it has never been confirmed, and it is worth saying so plainly. What is not in dispute is the chemistry. In 2008, all of this reached the public at once. That was the year Tuthill's team published the full analysis. The press did what the press does. Real Death Star could strike Earth. That was the actual headline. Fox News ran it, Space.com ran it. The nickname attached itself permanently, and Wolf-Rayet 104 stopped being a technical curiosity and became a loaded weapon with our address on it. Toot Hill himself was far more careful than his coverage. On his own technical page, which almost nobody read, he laid the caveats out plainly. Only about 1 in 100 Wolf-Rayet supernovae is thought to produce a gamma ray burst at all. Several links in the chain were uncertain, and what the imaging actually pinned down was the orbital axis of the pair, not the spin axis of the star that would do the exploding. His own summary was that maybe we are a little close for comfort to the danger zone, but there is still plenty of room for Earth to duck aside. Nobody reads the caveats. They read the headline, and then the news moved on and never came back. Which is how, years later, a stranger ends up typing a question into a university astronomy service, asking what the consensus on this star actually is now, explaining that it has become a source of anxiety and that no recent article can be found anywhere. The answer arrived in March of last year. On the 18th of March, 2025, Grant Hill, an instrument scientist at the Keck Observatory, the same mountain where the pinwheel was first photographed, published a new measurement in the monthly notices of the Royal Astronomical Society. He had not taken another picture. That was the entire point. Every previous estimate of this system's orientation traced back to the dust, to the shape of the spiral in an image. Hill went after the stars instead, using 3 separate spectrographs to watch how their light shifted as they swung toward us and away from us across that 241-day orbit. Motion along the line of sight leaves a fingerprint in a spectrum, and from that fingerprint you can recover the true tilt of an orbit without ever resolving it. The answer came back at 30 to 40 degrees out of the plane of the sky at minimum. 30 is not 12. 40 is not 12. Against a beam that opens perhaps 12 degrees, that is not a near miss. It is a comfortable, unambiguous miss. Whatever WR104 does when it dies, it will not be doing it to us. That should be the end of it. It is a good ending. It is the ending that Stranger was looking for, except for one thing. Our view of the pinwheel, Hill pointed out, absolutely looks face on, and it had seemed a perfectly safe assumption that the 2 stars were orbiting the same way. They are not, and the spiral has not changed. It is still there, still open, still symmetrical, still presenting its geometry straight to the camera. Go back to what that spiral actually is. It is not an ornament draped around the system. It is soot, laid down by 2 stars going round and round in the exact plane in which they travel. The orbit is the machine. The spiral is the print. And the print does not match the machine that made it. Nobody currently knows how that is possible. There is no accepted mechanism for a dust spiral tilted differently from the stars drawing it. In Hill's own words, WR104 is not done surprising us yet. So read carefully what actually happened here. We did not discover that this star is harmless. We discovered that the one thing visible from 8,000 light years away, the shape, the only part of the system that ever showed up in an image, does not tell you the truth about the geometry underneath it. The alarm was wrong, but so was the instrument that raised it, and that part has not been fixed. There are 642 Wolf-Rayet stars in the catalogue. Estimates of how many are actually out there in the Milky Way run from about 1,200 to nearly 2,000, which means the list we have may be somewhere around half of the real one. Not half of a rare thing, half of the population of the most dangerous class of star we know how to name. Now ask the question that follows. Of those 642, how many have we imaged the way we imaged this one, resolved closely enough and in enough detail to say which direction the thing is aimed? Essentially 1. That gap is easy to miss, so it is worth being precise about it. A catalogue is a list of names. It records that a star exists, roughly where it sits, and what class it belongs to. It says nothing whatsoever about which way that star is facing. Orientation is not a property you can look up. It has to be measured, one object at a time, and for almost every one of those 642, nobody has ever tried. WR-104 was the prototype. The first pinwheel, the bright one, the near one, the easy one. The case you use to prove a method works before you point it at anything harder. And on the easy one, two independent methods disagreed for 16 years, and the disagreement is still open. The sentence most people took away in March of last year was that we are safe. The more accurate sentence is that we are unmeasured. Those are not the same sentence, and only one of them is supported by the data. And there is a reason the catalog is incomplete that has nothing to do with bookkeeping. Wolf-Rayet stars live in the galactic plane, in the crowded star-forming regions where massive stars are born and die quickly. Those regions are thick with dust, a good deal of it manufactured by the very objects we are trying to count. So, a large part of our own galaxy is simply opaque. Invisible light we cannot see through the disk we live in. Infrared surveys keep pulling more of these stars out of the murk, which is why the population estimates keep moving. And it means the ones still missing are not a random sample. They are preferentially the hidden ones. The ones behind the most material. The ones in the thick of it. There is a second trap in the arithmetic, and it is the one people fall into hardest. The narrowness of the beam sounds like good news, and mostly it is. A 12-degree jet misses almost everything. But that same narrowness is why you cannot reason from the fact that we are still here. Every burst that ever missed us left no mark at all. There is no record of the near ones, no scar, nothing to count. The absence of evidence in this particular case is not weak evidence of safety. It is the expected result either way. What we can say is a rate. Modeling puts a dangerously close gamma ray burst at somewhere around twice per billion years. Life has been on this planet for roughly 3.8 billion. That is not a threat that has never materialized. It is a threat on a clock longer than civilization and considerably shorter than biology. And if Mullott and Thomas are right about the Ordovician, we are not speculating about the first entry in that log. We are standing on it. None of it would be announced. There is no siren for this. For the beam and the news of the beam are the same thing, traveling together. And the first indication would be an atmosphere that had already begun to come apart. Come back one last time to Toot Hill's phrase. Plenty of room for Earth to duck aside. It is a strange image once you sit with it. A planet with no say in the matter, no notice, and nowhere in particular to go, described as though it could step out of the way. It is the most human sentence in this entire story, and it is doing a very human thing. Making a geometry problem sound like a decision. The spiral is still turning out there, once every 241 days, patiently, the way it has been turning the whole time. Since that first photograph in 1999, it has completed roughly 41 more rotations. It will manage a few 100,000 years more, and then it will stop. And two jets will leave along an axis we have now measured twice and contradicted ourselves about both times. The current best answer is that they will miss us. That answer is probably right. It is the way to bet, and nothing here is an argument for being afraid of this particular star. It is an argument about what we actually know. For 26 years, the most frightening object in the sky was frightening because of a photograph, and the photograph was not wrong. It is still there, still face on, still showing exactly what it showed in 1999. What was wrong was our confidence that we understood what we were looking at. The image never changed. Only our reading of it did, and it took a completely different instrument, pointed at a completely different part of the system, to catch it. That is the uncomfortable shape of this whole story. Not that something out there is aimed at us. Something almost certainly is somewhere in that half of the catalog we have never seen. It is that the only tool we had for checking has now failed its one test case, and nobody has explained why. The universe is not aiming at you. That is the part people get backwards. There is no intent out here, nothing that knows your name, no malice in any of it. It is only that a few things are pointed in your direction anyway. And the difference between those two facts has never once mattered to anybody it happened to. The void is patient. So is that spiral.